Hello everyone. Today I would like to ask you, has it ever happened with you that you have got angry on someone, somebody you had a fight with and you had, okay, I'm going to take a revenge from him. Has it ever happened with you? Well, remember, anger and this kind of revenge that you feel like taking is like holding on to coal, that is hot coal. Now what would happen? It won't be harming the person at whom you'll be throwing, because before that is going to harm you, because you are holding hot coal in your own hands. So please, my dear children, always think out of this revenge attitude. Please never think of taking revenge from people. Please develop the habit of forgiving people. In this lecture, we are going to talk about pressure, but pressure about gases and liquids, how it is being affected. And also we will be talking about atmospheric pressure, the SI unit of pressure, and we will try to talk about balancing of blood pressure and atmospheric pressure. So let's begin the session. The substances such as hydrogen, helium, oxygen, nitrogen and carbon dioxide are gases. All the gases exerts pressure on the walls of their containers. Though pressure is exerted by all the gases, but since air is the most common gas, therefore we will discuss the pressure exerted by air. Air exerts pressure in all directions. It is a mixture of gases. All the gases are made up of tiny particles called molecules, which move around quickly in all directions. The fast moving gas molecules collide with one another and with the walls of the container in which they are kept. When the fast moving gas molecules collide with the walls of their container, they exert a force on the walls of the container. This force produces gas pressure or air pressure. So we may say that air pressure arises due to the constant collisions of the tiny molecules of the gases present in air with the walls of the container or vessels in which it is enclosed. So, if a certain mass of air is compressed into a smaller volume, say using a pump, then the number of collisions of air molecules per unit area increases, and hence the pressure exerted by air goes up. And if the container of air has stretchable walls like the rubber balloon, then the higher pressure exerted by air inflates the container, increases the size of the container and makes it look bigger. High air pressure produced by the gas molecules on the walls of balloon causes it to expand and get inflated. Similarly, when air is pumped into a bicycle tube by using a pump, the bicycle tube gets inflated due to the air pressure exerted by the collisions of gas molecules in air with the inner walls of the rubber tube. This air pressure in the bicycle tube makes the bicycle tube feel hard. Thus, the two examples that gases like air exerts pressure are: when air is filled into a balloon with our mouth, the balloon gets inflated or it gets bigger in size. And when air is filled into a bicycle tube with a pump, the tube gets inflated and makes the tire feel hard. We live on the earth and there is a lot of air above us. The layer of air above the earth is called atmosphere. The air in our atmosphere extends up to about 300 kilometers above the surface of earth. The atmosphere contains a tremendous amount of air. Air has weight. So, the atmosphere consisting of tremendous amount of air has enormous weight. The weight of atmosphere exerts a pressure on the surface of the earth and on all the objects on the earth, including ourselves. This pressure is known as atmospheric pressure. Just as pressure in a liquid acts in all directions, in the same way, atmospheric pressure also acts in all directions, even upwards. We know that pressure is force per unit area. Now, if we imagine a unit area of Earth's surface and a very tall column filled with air standing on it, then the weight of air in this column will be the atmospheric pressure at that place. Since the SI unit of area is square meter, therefore we can also say that atmospheric pressure is equal to the weight of air present in a very tall column of air standing on 1 square meter area of the earth. On the surface of earth, the atmospheric pressure is maximum at the sea level. This is because the column of air above us is tallest at the sea level. The atmospheric pressure on the surface of earth is 101.3 kilopascals, which is equivalent to the weight of 10 elephants pressing on each square meter area. Astonishing, isn't it? Thus, the magnitude of atmospheric pressure is very large. As we go up in the atmosphere from the surface of the earth, the atmospheric pressure goes on decreasing. This is because as we go up in the atmosphere, the weight of air above us goes on decreasing, due to which the pressure also goes on decreasing. So, the atmospheric pressure on the top of a high mountain will be much less than at its base. Well, we must note here that though the SI unit of pressure is Pascal, but atmospheric pressure is usually measured in the unit of millimeters of mercury or mm of mercury for the sake of convenience in measuring it. Thus, the common unit for expressing and measuring atmospheric pressure is millimeters of mercury. The atmospheric pressure on the surface of Earth or at the sea level is 760 millimeter of mercury. A very important question now arises in our mind that if the pressure due to atmosphere is so great, then why are we not crushed by it? Well, our body has a liquid called blood, which flows through blood vessels into each and every cell of our body. Our blood itself exerts a pressure called blood pressure, which is slightly greater than the atmospheric pressure. Since the atmospheric pressure acting on our body from outside is balanced by the blood pressure acting from inside, we do not get crushed. We use many simple devices in our everyday life which works on the existence of atmospheric pressure. For example, the devices such as drinking straw, a syringe, a dropper, and a rubber sucker works on the existence of atmospheric pressure around us. The drinking straw is a very thin pipe which is used to drink soft drinks like Coca-Cola or Pepsi. The drinking straw works on the existence of atmospheric pressure. This can be explained by the fact that the lower end of the drinking straw is dipped into the soft drink. When we suck at the upper end of the straw with our mouth, the pressure of air inside the straw and in our mouth is reduced. But the pressure acting on the surface of the soft drink is equal to the atmospheric pressure. So, the greater atmospheric pressure acting on the surface of the soft drink pushes the soft drink up the straw into our mouth. A glass tube or plastic tube with a nozzle and piston for sucking in and ejecting liquid in a thin stream is called a syringe. A syringe may also be fitted with a hollow needle for giving injections. The syringe works on the existence of atmospheric pressure. When the nozzle of a syringe is dipped in a liquid and its position is withdrawn, the pressure inside the syringe is lowered. The greater atmospheric pressure acting on the surface of the liquid pushes the liquid up into the syringe. A dropper is a short glass tube with a rubber bulb at one end and a nozzle at the other end. A dropper is used for measuring out drops of a liquid, such as a liquid medicine. A dropper works on the existence of atmospheric pressure. When we press the rubber bulb of the dropper by keeping its nozzle dipped in the liquid, air pressure in the gas tube and bulb is seen to escape in the form of bubbles. Due to this, the air pressure inside the glass tube and rubber bulb of dropper is very much reduced. When we now release the rubber bulb of dropper, the much greater atmospheric pressure acting on the surface of liquid pushes the liquid up into the dropper tube. Thus, the rise of liquid, say water, in a dropper is due to the atmospheric pressure. If we remove the filled dropper from the container of liquid and press its rubber bulb slowly, then the drop of liquid will come out of the nozzle of dropper tube. Just like a dropper, the filling of ink in a fountain pen is also based on the existence of atmospheric pressure. A rubber sucker is a device made of rubber or plastic that sticks firmly to flat and smooth surfaces on pressing. A rubber sucker looks like a small, concave-shaped rubber cap. A rubber sucker is also called a suction cap because it sticks to the surface by suction. When we press the rubber sucker on the flat, smooth surface, its concave rubber cap gets flattened to a large extent, pushing out most of the air from beneath. Since very little air remains inside the flattened rubber sucker, therefore the air pressure inside the rubber sucker becomes very low and a partial vacuum is created. The much greater atmospheric pressure acting on the rubber sucker from outside fixes the rubber sucker firmly on the flat surface. Thus, a rubber sucker stays attached firmly to a flat surface due to the atmospheric pressure. In order to pull away the fixed rubber sucker from the surface, we have to apply a force which is large enough to overcome the atmospheric pressure holding it onto the surface. Rubber suckers are usually used to hold objects together with the help of suction. Atmospheric pressure at a place is measured by a barometer. Thus, a barometer is an instrument which is used to measure the atmospheric pressure. There are three types of barometer which are commonly used: the simple barometer, the 14th barometer, and Android barometer. The atmosphere can be considered to consist of a number of parallel air layers. Each layer experiences a pressure on it due to the thrust or weight of the air column above it. Therefore, as we go up, the height of the air column decreases, and so the thrust exerted by air column also decreases, due to which the pressure of air decreases with increase in altitude. Apart from this, the lower air layers get compressed due to the weight or thrust of the upper layers. Therefore, the density of air layers is more near the Earth's surface, and it decreases as we go higher and higher. The decrease in density with altitude is not linear. It is rapid at low altitude near the sea level and is slow at higher altitude. Due to decrease in density of air with altitude, the atmospheric pressure also decreases with altitude. Thus, the decrease in atmospheric pressure with altitude is due to the following two factors. Number one, the decrease in the height of air column, which causes a linear decrease in the atmospheric pressure. And number two, decrease in the density of air, which makes the decrease in atmospheric pressure less rapid with the increase in altitude. The weather can be forecasted by the use of a barometer. The atmospheric pressure at a place is affected by the change in temperature and the amount of water vapor present in air at that place. The reason is that the density of air changes with the change in temperature and with the change of water vapors present in it. Consequently, the atmospheric pressure or the barometric height decreases as the temperature or the presence of moisture increases. Thus, the change in the atmospheric pressure helps us to know about the weather in advance. If the barometric height at a place suddenly falls, it means that the pressure at that place has suddenly fallen, which indicates the coming of storm or cyclone. If the barometric height gradually falls, it indicates that the moisture is increasing, that is, there is a possibility of rain. A gradual increase in the barometric height means that the moisture in air is decreasing. This indicates a dry weather. If there is no abrupt change in barometric height, it indicates that the atmospheric pressure is normal, that is, the weather is fair. So, what have we learnt in this lecture? Let us do a recap of that with the help of mind map. Check over here. In this topic we were discussing pressure, but mind it, we have talked about liquid and gas pressure. So liquids and gases exerts pressure on the walls of the container. This becomes one branch of the mind map. The second branch that we should be having, the most important topic, is the atmospheric pressure. And what is the atmospheric pressure? It is the pressure exerted by the atmosphere, the column of air that we have, the blanket of air. The pressure exerted by that is known as atmospheric pressure. That becomes the second branch. Come to the next thing. I'll talk about SI unit, very important. What is the SI unit of pressure? The SI unit of pressure is Pascal, right? Pressure, force per unit area. So this Pascal may also be said as force, SI unit being Newton, and area, SI unit being meter square. We have Pascal is equal to Newton per meter square. So it can be Newton per meter square as well. Last thing that we can talk about over here is we have talked about blood pressure. Remember, we have mentioned that when we are at high altitude, or when we are on this earth also, we do not get crushed by the atmospheric pressure. The reason is what? The reason is the pressure of our blood is being balanced by the atmospheric pressure. That becomes my fourth branch. Pressure inside our body due to the blood is balanced by the atmospheric pressure. So this is, in a nutshell, we have talked about liquid and gaseous pressure. Brings me to end of lecture number 5. Well, by now I believe you all must be aware with my email ID. It's sanyal.shankha@gmail.com. My dear children, please do write to me. In case you have any queries, I would be really grateful to answer them. My dear children, stay blessed. Thank you.